The interference in the computer screens, resulting in a waving effect, is likely due to several factors related to the proximity of the job trailers to the high-voltage power lines. The primary cause is electromagnetic fields, or EMFs. High-voltage power lines generate strong electromagnetic fields that can interfere with electronic devices. Another potential cause is electrical noise. The electrical current flowing through the power lines can create electrical noise that can be picked up by the devices. Finally, poor grounding can create ground loops that can also cause interference. To mitigate the interference, there are several steps that can be taken. Firstly, ensure proper grounding. Ensure that all job trailers and temporary service are properly grounded. Use multiple grounding rods and connect them together with copper wire. Secondly, consider shielding. Consider using shielded cables for all computer connections. Install metal shielding around the trailer walls and windows to block EMF. Thirdly, use surge protectors. Use high-quality surge protectors to suppress electrical noise and protect electronic devices. Fourthly, install power line filters. Install power line filters between the temporary service and the job trailers to reduce electrical noise. Fifthly, optimize cabling. Keep cables as short as possible to minimize inductance. Avoid running cables parallel to the power lines. Sixthly, increase distance. If possible, move the job trailers further away from the power lines to reduce the strength of the EMF. Seventhly, consult with the power company. Contact your local electric utility and explain the situation. They may be able to provide further assistance or recommend mitigation measures. Eighthly, consider other options. Use laptops with battery power instead of being plugged into the electrical grid. Consider portable enclosures or tents to protect devices from EMF. Install an electromagnetic field reducer or filter, or EMFer, on the power line. To elaborate on grounding, proper grounding is crucial for minimizing interference. Grounding provides a path for stray currents to return to the source, reducing the potential for voltage differences that can cause interference. Use multiple grounding rods, typically 8 feet in length, driven deep into the earth. Connect these rods together with heavy-gauge copper wire, creating a grounding grid. Ensure that all trailers and electrical equipment are connected to this grounding grid. Check the ground resistance with a ground resistance tester to ensure it meets the required standards, typically 25 ohms or less. For shielding, shielding involves creating a barrier that blocks electromagnetic fields. Use shielded cables, such as coaxial cables or twisted pair cables, for all computer connections. These cables have a metallic shield that surrounds the conductors, preventing EMF from entering or leaving the cable. Install metal shielding around the trailer walls and windows. This can be achieved by using metal mesh, foil, or specialized shielding paint. Ensure that the shielding is properly grounded to maximize its effectiveness. When it comes to surge protection, surge protectors are designed to protect electronic devices from voltage spikes and surges. These devices can divert excess voltage to ground, preventing it from damaging sensitive equipment. Use high-quality surge protectors with a low clamping voltage, typically below 400 volts. Ensure that the surge protectors are properly grounded to function correctly. Install surge protectors at the main electrical panel and at each individual device. Power line filters are designed to reduce electrical noise on the power line. These filters use inductors and capacitors to block high-frequency noise while allowing the desired power frequency, usually 60 Hz, to pass through. Install power line filters between the temporary service and the job trailers. Choose filters with appropriate voltage and current ratings for the application. Cabling practices can also affect interference. Keep cables as short as possible to minimize inductance. Inductance is the tendency of a conductor to resist changes in current flow, which can contribute to electrical noise. Avoid running cables parallel to the power lines. Parallel cables can act as antennas, picking up electromagnetic radiation from the power lines. Instead, run cables perpendicular to the power lines to minimize interference. Increasing the distance between the job trailers and the power lines is one of the most effective ways to reduce interference. The strength of electromagnetic fields decreases rapidly with distance. If possible, move the trailers further away from the power lines. Even a small increase in distance can make a significant difference. When consulting with the power company, the local electric utility may be able to provide further assistance or recommend mitigation measures. They may be able to identify the source of the interference and suggest solutions. They may also be able to adjust the voltage or current on the power lines to reduce EMF emissions. When using laptops with battery power, operating laptops on battery power eliminates the connection to the electrical grid, reducing the potential for ground loops and electrical noise. Ensure that the batteries are fully charged and in good condition. Consider using uninterruptible power supplies or UPSs to provide backup power in case of a power outage. Portable enclosures or tents can protect devices from EMF. These enclosures are made of materials that block electromagnetic radiation. Ensure that the enclosures are properly grounded to maximize their effectiveness. Install an electromagnetic field reducer or filter or inverter on the power line. An inverter is a device that reduces the strength of electromagnetic fields emitted by the power line. An inverter typically contains a combination of inductors, capacitors, and resistors that are tuned to specific frequencies. The device is installed in series with the power line and reduces EMF emissions. Note that it is important to consult with a qualified electrician or engineer to determine the most effective solutions for the specific situation. They can assess the specific conditions, perform measurements, and recommend the most appropriate mitigation measures. The electrician or engineer can conduct a thorough site assessment to identify the sources of interference and evaluate the effectiveness of different mitigation techniques. They can use specialized equipment to measure electromagnetic field strengths, electrical noise levels, and ground resistance. Based on the assessment, they can recommend the most effective solutions for the specific situation. This includes selecting the appropriate grounding techniques, shielding materials, surge protectors, and power line filters. They can also provide guidance on cabling practices and equipment placement to minimize interference. The electrician or engineer can also ensure that all work is performed in accordance with applicable electrical codes and standards. This includes ensuring that all grounding and bonding connections are properly made and that all equipment is installed in a safe and reliable manner. Regular inspections and maintenance are essential for ensuring the continued effectiveness of the mitigation measures. The electrician or engineer can conduct periodic inspections to check the condition of the grounding system, shielding materials, surge protectors, and power line filters. They can also perform measurements to verify that the interference levels remain within acceptable limits. If any problems are identified, they can recommend corrective actions to maintain the effectiveness of the mitigation measures. Keep detailed records of all inspections, maintenance, and repairs. This documentation can be helpful for tracking the performance of the mitigation measures and for identifying any trends or patterns. It can also be useful for demonstrating compliance with applicable regulations and standards. When selecting grounding techniques, consider the soil conditions and the local electrical codes. In areas with high soil resistivity, it may be necessary to use multiple grounding rods or to install a chemical ground rod to achieve the required ground resistance. Also, ensure that all grounding connections are made with corrosion-resistant materials to prevent degradation over time. When selecting shielding materials, consider the frequency range of the electromagnetic fields that need to be blocked. Different materials have different shielding effectiveness at different frequencies. Metal mesh and foil are effective at blocking high-frequency fields, while specialized shielding paints are effective at blocking low-frequency fields. Ensure that the shielding materials are properly installed and grounded to maximize their effectiveness. When selecting surge protectors, consider the voltage and current ratings of the equipment that needs to be protected. Choose surge protectors with a low clamping voltage to provide the best protection against voltage spikes. Also, ensure that the surge protectors are properly grounded to function correctly. When selecting power line filters, consider the frequency range of the electrical noise that needs to be filtered. Different filters have different attenuation characteristics at different frequencies. Choose filters with appropriate voltage and current ratings for the application. Also, ensure that the filters are properly installed and grounded to function correctly. By following these steps, it is possible to effectively mitigate electromagnetic interference from power lines and ensure the reliable operation of electronic equipment. Remember to consult with a qualified electrician or engineer to determine the most appropriate solutions for the specific situation. They can provide expert guidance and ensure that all work is performed safely and in accordance with applicable codes and standards.